Hello and welcome. In this video, I'm going to showcase the new BitcoinCash Dapp I built within 24 hours. It's called BCH HODL Dapp. And this video is mainly targeted at some of the new developers who've been watching my channel and want to learn how they can also get started building BitcoinCash Dapps. So we'll dive into some of the technicals about how this works with smart contracts and Wallet Connect. So as you can see, there's a Wallet Connect button at the top, and some of the other pages only display stuff when you have connected your wallet. So I didn't spend too much time on the layout. It's mainly about the functionality. And this idea of the BCH HODL Dapp, it's actually based on an existing project of the same name, but which was a smart contract a plugin for Electron Cash. And this project is by Mainnet Pat. He also wrote a retold cash blog post titled HODL Smart Contract Plugin for Electron Cash to Time Lock BCH. And it explains how it works and also has some screenshots about how you use this plugin to create a new time-locked contract. But the drawback of this is that you needed to install a plugin on your computer, and it only worked with the Electron Cash wallet. So with my Dapp, it's a website, so it's in the browser, and it works with Wallet Connect. So if you press Connect Wallet, then you can copy this QR code. I'm using now Cashanize, and I'll connect to this application. Then we approve, and now I have successfully connected. So you can see my balance, the address that is connected, and now we can also move to the other pages. So we can see there's actually 3 contracts connected to my address, and we can also create a new HODL contract. And for example, if we put in one test Bitcoin Cash and block height 250,000, create contract, then we will get a pop-up in Cashanize for create a HODL contract, and then we can see the full transaction details if we want. So we have one big input from this wallet, and we have 3 outputs. The first is a data output. It's just a marker indicating this contract on chain. And then there is the one BCH going to the contract address. And then there's the change output sending all the remaining Bitcoin Cash back to the Cashanize wallet. So this is how the Dapp works. You connect your wallet, and then you can easily create a new contract, or also if you have existing contracts where you can spend from, because of course the time lock needs to be reached. The block height that you fill here will be the block height until which the funds are locked. But for example, here I have a time lock which has expired, so I can reclaim the funds to my wallet. And you will see in Cashanize that there's now a pop-up, reclaim HODL value. And if you look at the transaction details, we see that I created before a smart contract at this smart contract address of 0.1 test Bitcoin Cash. And now I can spend from it, so almost the full amount minus a transaction fee. So yeah, I can press sign to actually spend from this transaction, or from this smart contract, which I'm not going to do now. So this demonstrates kind of the scope of the smart contract application and what it was inspired by. So now let's take a look at the code for the whole application. And it lives in the repo BCH HODL Dapp under my username on GitHub. And first of all, let's take a look at the dependencies. So in the package.json, we can see what other libraries and tools I use to build this. So of course, I use libauth, like in many of my other videos, for utilities related to Bitcoin Cash. Then there's 2 dependencies for Wallet Connect, for the modal, so this is the pop-up, and also for the sign client, which does the interaction with Cashanize in this case. Then we're also using CashCrypt. I'm also using ChainGraph.ts, which is a helper library I created for interacting with ChainGraph. And then these last dependencies are for Vue. So this is Vue itself, the router utility, and Pinia as the state solution for Vue. So now let's take a look at the actual code of how the interaction for this works. If you want to create a HODL contract, what is happening with CashCrypt behind the scenes, and how does this communicate with Cashanize? So that's what we want to learn right now. So we need to take a look at the source code, and this will be in the actual views. So you see there's 3 pages, all contracts, which is the home page, then user contract and create contract. So we want to first take a look at create contract, which is here. So we have a bunch of imports at the top, and then the function, which we're already interested in, propose wallet connect transaction. And so we'll take a look. It first initializes the contract. So you can see new contract gets initialized here. We get the balance and get the BCH, the user's BCH UTXOs. And we do some extra preparation work. But then here we see we invoke the transaction builder. So here is actually where the transaction building starts, with adding the inputs, adding the op return, like we saw before, adding the output to the smart contract, and then adding a change output back to the user. And then we do transaction builder.build. So here is where the transaction building actually happens. And an important part is that if we want to spend from the user input UTXOs, we cannot actually do this because this is where CashNice comes in, and CashNice has to sign this. So instead of being able to create a signature, we use a placeholder unlocker, which looks like this. So it's of the type unlocker. But if you look at how we unlock this, it's actually just an empty unlocking bytecode, meaning that this communicates to CashNice, you need to sign this input because it's using a placeholder. So this is very important for the wallet connect part. And then also for the wallet connect part, we want to create this wallet connect transaction object. So it has the decode transaction. So after doing .build, we actually want to decode the transaction to pass it to the wallet connect object. We also need the source outputs. So I'm using a helper function here to get from the transaction builder input to generate the source outputs. So then we have the first 2 things. And then you simply provide whether you want the wallet to broadcast the transaction and what you want to tell the user. So these are simple enough. And then to actually wait for CashNice to sign this, we use sign transaction and then communicate this wallet connect transaction object. And as you can see, this is using the store. So let's quickly move to the store and then scroll down until we see that function. So this is initialize wallet connect and then sign transaction. So we use the sign client, and the sign client was also the helper library that we're using from wallet connect. So there's wallet connect sign client. So this is the class, and then we initialize this class, and then we have a sign client with a sign client instance, which starts with a lowercase. And then this is what we're using to actually talk to CashNice. So just these few lines. So we pass a wallet connect transaction object, and then we stringify and parse it. So this is a bit of a workaround, but this is the way you can communicate this object to CashNice. And then you need a few other parameters as well, namely you need the method, and we want to sign a transaction. So of course the method is BCH _ sign transaction. And then you also need to provide the topic and the chain ID. And that covers it. So that is how the create contract communicates with CashNice through Wallet Connect. And this documentation is also something I added to the Wallet Connect page on CashCrypt. So if you go to next.cashcrypt.org, and so within guides, you see Wallet Connect. It first lays out this Wallet Connect transaction object with a link to the specification. And then it talks about how you can create this Wallet Connect transaction object using the HODL Vault tab as example. And as we saw before, we use the unlocker, then we use the transaction builder, we construct the decoded transaction and the source outputs, we have the whole Wallet Connect transaction object, and then lastly, we use this sign Wallet Connect transaction helper function. And I also added it here to the very bottom. This is the sign transaction wallet interaction. And here we can see that we need the sign client, which we import from the library @walletconnect/sign client. And here is the same code we looked at before, but added to the CashCrypt documentation. So again, we use this Wallet Connect transaction object and pass it as a parameter to the sign client request object. So that's what's happening. And then there's also a second example. So the first example is spending a user input, but then there's a second example, spending from a user contract. And as you can see, this is using the unlock HODL vault code of the HODL vault tab. So this is what happens if you go to user contracts and reclaim to wallet. Then we're actually spending from a smart contract. So the code will look a bit different. And let's investigate it now. So that's in the user contracts. And we want to specifically take a look at the code to unlock the HODL vault contract. So as before, we see some setup to create a contract. We see that we want the contract UTXOs and balance. And then here we actually have the transaction building taking place. And as before, our end goal is to construct this wallet connect transaction object. But we'll take a closer look at what's happening with the transaction builder. So notice here how we do transaction builder.set lock time, because we actually want to satisfy this time lock. So we have in the contract a time lock condition. So here we set the current block height, which we get from the store. We set this current block height as a parameter in the transaction builder. Then next up, as an input, we no longer provide a user input, right? Because that's what we're doing when we're creating a new transaction. But here we want to spend from an existing smart contract. So we pass in UTXOs, and then the unlocker here is a function on the smart contract. So this HODL contract, let's use some highlighting. This HODL contract is initialized higher up, so it's initialized here. And to spend from this HODL contract, we use HODL contract.unlock and then the spend function with the necessary arguments. And these are two arguments that are necessary, the public key and the signature. But we don't know what the public key and the signature from the user are, because those need to be provided by CashNice or by the connected wallet. So again, we use placeholders. And for this, you can also refer to the documentation. To signal that a wallet needs to sign an input, the app sets the corresponding inputs unlocking bytecode to an empty uint8 array. So this is what we did before. But then also important is we signal the use of public keys by using 33-byte long zero-filled arrays and by using 65-byte long zero-filled arrays for snore signatures. So these are the two values, 33 and 65. And if you take a look at this, 33 and 65, so you pass in these two placeholders as arguments to the unlock function. And then once we communicate this object through CashNice, CashNice will know that it needs to fill in these two placeholders. So it will fill in the public key, fill in the signature, and then this will be a valid transaction. So let's actually try that. So if we reclaim to wallet, we get a pop-up in CashNice. Yeah, and then CashNice actually fills in these transaction details behind the screen. So if we press sign, we see sending transaction and transaction successful. And we actually receive the value back. We can also investigate this on the block explorer and also see it in the transaction history as an unconfirmed transaction. So everything is working nicely. We have spent, and we even get a notification here that we successfully reclaimed from that HODL vault. So everything is working, and this is what we just saw in action. We just saw that in the user contract, we used this transaction building to spend from the contract with two placeholder arguments. We constructed a wallet connect transaction object, and then we used the sign client through this helper function to actually communicate with CashNice, and CashNice did the broadcasting, because remember we said broadcast to true. So CashNice has actually sent this transaction to the network and spent from this smart contract. So that is the overview of what I've built. There's a bit more to it. So you can read more about the extra logic in the store. For example, how I'm using chain graph with the fetch HODL contract, or you can also take a look at how this wallet connect stuff is initialized. So you see here, initialize wallet connect, and you also see wait for a function. And let's see if there's anything else. Besides that, the store is quite basic, but the reason I'm using a store is that you have a bit of global state in this application. So for example, everything related to Wallet Connect, it doesn't matter if you're in a home page or on the My Contracts page or on the Create Contract page, it will always have this same state about the balance, the user address, the session, and also some of the fetched info will also be stored in the global store for this application. So that's me showcasing how this all works. I hope that helps understand how creating a contract and spending from a smart contract actually works. And I want to refer also again to this guide on the CashCrypt documentation page, which makes it easy to work with Wallet Connect. So I hope that was helpful. Thank you for watching the video and see you in the next one. Bye bye.